All right, calculate the average rate of change of the function f of x equals 3x squared over the interval 1 to 5. Average rate of change is the same thing as slope, okay? So then you have to figure out how to calculate slope. Well, on your EOC, it will be on the formula sheet. So you'll click the formula sheet, it'll drop down, and you will use the slope formula. To use this formula, we need what? 2 points. Okay, because we need an x1 and a y1, and we need an x2 and a y2. That way we have 4 numbers to plug in the slope formula. Did they give us any of that information? Right. Interval is x values, and if you weren't sure of that, there's an x between them that will remind you that 1 is an x value, 5 is an x value. How can we now use those x values to find their y value? Plug them in the equation they gave you. This equation is the equation of a what? What kind of graph will that make? A parabola, because it's squared, it's quadratic. So the first time I'm going to plug in a 1, the second time I'm going to plug in a 5, and then I just calculate that. 1 squared is 1, 1 times 3 is 3, 5 squared is 25, 25 times 3 is 75. Now I have the y value that goes with 1, and it's 3, and the y value that goes with 5 is 75. And now I just plug them in the formula where they go. So it'll be m equals 75 minus 3 over 5 minus 1, which becomes 72 over 4. And 72 over 4 is 18. Okay, so turn to page 20. We're starting Unit 4 today. A certain population of bacteria has an average growth rate of 2%. The formula for the growth of the bacteria's population is A equals P sub 0 times 1.02 to the T power, where P sub 0 is original population. So that P sub 0 represents the original population, and T is time in hours. So that T represents time in hours. If you begin with 200 bacteria, about how many bacteria will there be after 100 hours? So what do you need to do? Okay, they gave you the formula to use. They told you what all of the variables mean. So what can we do now? Correct. We begin with 200. Well, didn't they tell you P sub 0 is original population? 200 is the original population. It's just P for population, 0 for 0 hours. And then times 1.02. I'm going to write times like that just because it looks funny otherwise. To the T power. But what can I plug in for T? 100. And so now all you have to do is type that right in your calculator just how you see it. 200 times 1.02 raised to the 100th power is what? Okay, and now it looks to me like there's a small typo on these answer choices, but you would pick what? C. It looks like this should have been a 4 right here, and it's just a typo. All right, number 58. Which function represents this sequence? Okay, so we have a table. The x values are 1, 2, 3, 4, 5. The y values are 6, 18, 54, 162, 486. Do you notice a pattern? What's the pattern? Right, they are multiplying by 3 every time. Okay, well, B doesn't even have a 3 in it, but the rest of them do. Do you know where the 3 should go? What kind of sequence is this? When you multiply to get to the next number every time, what kind of sequence is that? Geometric. Okay, geometric sequences are the sequences that you multiply to get each number after the previous. So you would then try to remember the formula. So you would use the formula A sub n, even though they used F of n, it's not a big difference. And then it equals the first term times the R value raised to the n minus 1. Okay, well, what would we plug in for the first term? Right, your first term is 6. And then you put what in the R place? 3. That's the ratio, right? That's what they're being multiplied by. And then normally we wrote the n minus 1 on the outside. They kept it on the inside, so it's D. Now, say that you were looking at this problem and you did notice the pattern was multiplying by 3, but you just really, nothing about geometric sequences came to mind, and so you didn't know to use this formula. Another way that you could have figured it out is if you graph the other 3 choices. And I'll just start with D to save time and show you what would happen. If you go to y equals and you type in the choice for D, it's 6 parenthesis 3 raised to the n minus 1 parenthesis. Oh, but make sure you make the parenthesis big. And then I'm going to just go straight to the table because that's what I have on my paper is a table. And then look, isn't the first point 1, 6, and then 218, 354, 4, 162, 5, 486? Isn't that exactly what we see in our table? So that's another way you could have figured this out had you not known how to plug it in the geometric sequence formula. You could have just taken all 3 one at a time, put them in the calculator, gone to their table, and matched up the tables. All right, number 59. The points 0, 1, 1, 5, 2, 25, 3, 125 are on the graph of a function. Which equation represents that function? Okay, so what do you think you would do first? Okay, you could, but without just simply graphing all 4 and wasting the time to do that, could you like narrow it down and, okay, look at the pattern. To get from like one point to the next, what are they doing every time? Multiply by 5. So if you're going to graph, which one do you think you should graph first? D. Y equals 5 to the x power. And if you don't know that, if you can't figure out a pattern or remember to look, just graph all 4. Then go to the table, and then they gave us the point 0, 1, which is there, 1, 5, which is there, 2, 25, 3, 125. So this is obviously D. All right, number 60. Which function shows the function f of x equals 3 to the x being translated 5 units to the left? It is B. Remember, whenever you want to just go up or down, the number is at the very end. Like plus 5 would be up, and that would be choice D. Minus 5 on the end would be down. That would have been choice A. If you want the thing to shift left or right, you put the number with the x, and in this case, with the exponent. But it's opposite of what your common sense would tell you. Plus actually moves it left, and minus actually moves it right. And that's because of the formula already having a minus in it, which a negative will become a plus, so minus a left will become plus, and then minus a positive number, which is what you would really get going right, will keep it minus that positive number. Does that make, are y'all starting to understand more why left and right are opposite of what you think? Because the negative already in the formula changes the sign? All right, page 21, problem number 61. Which function shows the function f of x equals 3 to the x power being translated 5 units down? A. We just talked about that in the previous one. To go down, it's just minus 5 on the end, not with the x, just on the end. Number 62. Consider this pattern. Which function represents the sequence that represents the pattern? So what do you think would be a good idea to do first? To know the pattern, what do you need to do? Okay, so what should we do? Count them, right? How many squares are in the first thing? 1. How many are in the second thing? And how many are in this third thing? 16. Yeah, look. 4, 8, 12, 16. So, what's the pattern? multiply by 4. Okay, so any ideas which one's right? It's A. Remember, for geometric sequences, it's just the ratio raised to the n minus 1. What they're multiplying by is raised to the n minus 1. And yes, normally in front of that we put the first term, but isn't the first term a 1, so you don't have to write it? D is nothing. Like, that's nothing we've ever seen, nor is C. And then B is the only one that even looks similar, but is it ever A sub n minus 1 in the exponent? No. So none of these even make any sense. Now, once you are leaning towards one, try to graph it. You're going to have a problem graphing C or D, right? Because you're not going to know what to type in A sub n as. And then, but when you type A, watch what happens. 4 to the n minus 1. I'm just going to go straight to the table. 1 is 1, and isn't that how many squares were in the first figure? And then the second figure had 4 squares, and the third one had 16 squares. So that means A is right, because it matched up. All right, number 63. Okay, there is a mistake on number 63. On choice C, you need to put, on choice A, just put an X. On choice B, just put an X. On choice C, put X minus 1. And on choice D, put X minus 1. Now, how could we figure out which of these functions is the same function modeled in the table? We could graph it. Can you narrow it down at all? Okay. And then from there, couldn't you graph each one of these and see which one corresponds to that table? Okay. So let's start with C. 1,000 times 0.80 to the x minus 1 power. That's right. Oops. Okay, I'm going to go straight to the table and see if it matches the table on my paper. 1 1,000, 2 800, 3 640, 4 512. So it's C. Now, some of you were probably just able to look at it and see that the starting value was 1,000, and then from there, 80% of it remained in the next one. Because isn't 800 80% of 1,000? So 80% remains. Okay, number 64, page 22. Yeah, these are not as time consuming. Which explicit formula describes the pattern in this table? Okay, so what do you think I should do? Okay, do you see a pattern? 1 times 6 is, 6 times 6 is, and it's 36 times 6, 216? Yes, so the pattern is they are multiplying by 6. So in this one, that's adding 6. And that one, that's raised to the 6th power. So let's try out A first. C equals 6D. Well, the very first C value is 1. And the very first D value is 0. Does that make sense? Is 6 times 0, 1? No. So now let's try C. C equals 6 raised to the D power. The very first C value is 1. And then the very first D value is 0. Is 6 raised to the 0 power 1? Type it in if you're not sure. It is. Any number raised to the 0 power always equals 1. Any number. Okay, any number in the whole world raised to the 0 power equals 1. Now, if you do that one and you're not convinced, try the next one. Type in the next C value, which is 6, and then 6 to the D value that goes with that would be 1. Isn't 6 to the first power equal to 6? So it's C. All right, number 65. There's also a typo on this one. Change choice D inside parentheses to 0.50. Okay, so now it says if f of 12 equals 100 times 0.50 to the 12th power, which expression gives f of x? It's D, obviously. Okay, since I had to change it. If you're just going back and putting the X beside the F, then doesn't that mean right here where there's a 12, you need to go back and put an X there, and then that should have been a .50 in there? So it's D. All you're doing is going back and taking the 12s out and putting X's back in those places, which is what D did. All right, number 66. There's also a problem with this one. It's not a typo. It's just they didn't finish it. I need to write the question down here. They didn't actually state a question. What is the range of the function? Okay, and then choice A, I'm going to put any real number, and I'm going to abbreviate to save time. Any real number. Choice B, any whole number greater than 0. Choice C, any whole number greater than 5. Or D, any whole number greater than or equal to 5. Okay, does everybody have it copied now? Okay, the question says, a population of squirrels doubles every year. Initially, there were 5 squirrels. A biologist studying the squirrels created a function to model their population growth. P of T for population after T years equals 5 times 2 to the T power. Remember, 5 is first because that's how many squirrels they started the study with. Then they multiply that by 2 because they're doubling every year, and then to the T power for time and years. The graph of the function is shown. What is the range of the function? Well, when you hear the word range, you know we're thinking about the what? The y values, okay? Doesn't range have to do with the y values and domain is x values? So, like, what is the y value of this first point? What? It would be 5, right? And then the y value of this point is? Well, look, this is 0 and that's 20, so halfway between would be 10. And the y value of this one's 20, and then 80. So they just want to know the range of the y values, how low they go and then how high they go. Well, what's the lowest they go? 5. So you know it's got to be C or D. Is it any whole number greater than 5 that's in the range, or any whole number greater than or equal to 5? Greater than or equal, because isn't there a point actually at 5, because that's how many squirrels started the study, exactly 5? So you need that equal to sign because of that. There were exactly 5 when it started, and then from there it grew in population, so it became greater than 5. So D. All right, page 23, number 67. Okay, the function graphed on this coordinate grid shows f of x, which is the height of a dropped ball in feet after its x bounce. On which bounce was the height of the ball at 10 feet? Right. Here's 10 feet, and then isn't that bounce 1? So A. So pretty much how many bounces does it take for it to stop bouncing? Yeah, I mean, because at 4, it's still a teeny bit above. So by the 5th time, basically, it's not bouncing anymore. Or after it's bounced the 4th, that's pretty much it. Number 58, look at the graph. Let me zoom out some. Look at the graph. Which equation represents this graph? Okay, well, look at that and tell me some things you notice about the graph. Okay, what starts at 2? The asymptote. Okay, there's an asymptote at y equals 2 because the asymptote line cuts through the y-axis at 2. So which equation do you think would make that happen? Right. If everything gets shifted up 2 by that plus 2 on the end, then the asymptote will also move up to positive 2. Okay, page 24. Okay, this is now the start of Unit 5. Which scatter plot best represents a model of linear growth? B. Okay, A would be exponential growth because it curves and goes up. C would be linear but decay because it's going down. And then D, I mean, not really much correlation. If anything, a very weak linear growth, but this is the best linear growth. Okay, number 70. Which scatter plot best represents a model of exponential growth? Right, exponential is when it curves and growth would be going up, so A. B would be what kind of growth? Linear. C would be linear but going down. And then D, pretty much if you tried to draw anything, it would also have to be a line, but that would be weak positive correlation, right? This would be strong positive correlation. This would be strong negative correlation. Does anybody remember what the correlation coefficient is if it's very strong and it's positive? 1. Okay, like this would be a correlation coefficient, an R value of positive 1. And this would be negative 1. But then at this point, it would still be positive, but it might be like 0.6. The R might be 0.6 because it's getting weaker. And then if the points are just all over the place, what kind of correlation coefficient would that be? Very close to what? 0. Okay, the weaker it gets, and where you see no correlation at all, the closer the correlation coefficient gets to 0. It's always between 0 and 1, or 0 and negative 1 for graphs that go down. All right, page 25, number 71. Which table represents an exponential function? Okay, D is correct. What do A, B, and C all represent? Linear. Because in A, B, and C, look, plus 1, plus 1, plus 1, plus 1. It's adding the same thing every time, which would make a line. The slope would be 1 over 1. That's also an arithmetic sequence. B is plus 22, plus 22, plus 22, plus 22. So that makes a line with a slope of 22 over 1, because these are all going up by 1. And then what would the slope of C be? 8 over 1, because you're adding 8 every single time. So that's also linear. It's also an arithmetic sequence. But what's going on in D? Right, they're multiplying by 3, so it's a geometric sequence, and it would make a curve, an exponential curve. All right, number 72. A table of values is shown for f of x and g of x. Which statement compares the graphs of f of x and g of x over the interval 0 to 5? Remind me again what interval means? X values. So 0 is an x value, and so is 5. So I only care about those x values, which would be this point of this one and this one of that one. Those have the x values of 0, and then 5. Okay? The graph of f of x, which is the one on the left, always exceeds the graph of g of x over the interval 0 to 5. Well, let's look. For the f of x, when you went from 0 to 5, what did the f of x do? It went up 25, right? So that would be an increase of 25 over 5, which would be 5, correct? Over here, when it went from 0 to 5, so that's the run. X values are always the run, remember. The rise would have been from negative 2 to 29, which is a rise of 27. What is that? What's 27 over 5? 5.4. Okay, so now let's look at these answers. The graph of f of x always exceeds the graph of g of x over that interval. Which one's bigger, f of x or g of x? g of x. So A is wrong. F of x does not exceed g of x. B, the graph of g of x always exceeds the graph of f of x. Yes, so far. I don't really like this question because this is one of those where if you stop at that one, you'll get it wrong. Because technically, yes, so far that's right. But look down here at D, what D says. The graph of f of x exceeds the graph of g of x from 0 to 4, but then they intersect between 4 and 5, and then g of x starts exceeding. Well, we know in the end g of x is bigger, but now they're talking about 0 to 4. So now we got to look at 0 to 4. For this one would be a run of 4 and a rise of 16, correct? Because if you're just going from the 0 to the 4, isn't that a run of 4 and a rise of 16? Which is 4. And over here in g of x from 0 to 4 is a run of 4 again, but a rise of 11, because you're going from a negative 2 to a 13. So that's 11 units. And 11 over 4 is... Right. So can't you now see how at first f of x is going faster, but then at some point g of x starts going faster? So it's actually D. You really need to, if time allows, to even after you feel like you have an answer, read the other choices and just make sure that they're wrong. Okay. What? Yes, we'll stop now and do the schedule. Go ahead and get out your schedules. What days did we go over so far? We're on Friday? Okay. Hold on, let me do this. Okay, I'll have to do it with you like maybe one-on-one tomorrow. Okay, Friday. Next Friday is when juniors start taking their literature EOC, and the first day they'll do the writing portion just like y'all did. So you'll come in, you'll go to your first period just like we do every day for a 10-minute attendance. Then at that point, you're going to report to your second period for the testing time. Now, you won't be testing, but that doesn't mean that you will be in the room that you always are. Okay, so you think about who your second period teacher is, which obviously for y'all is me. And I am not testing, but they are using my room for testing. So if we look below this, down here, it will show that Brooke J's class goes to M16. So let me just do this for third period since they'll be seeing this on video. You need to be thinking about your second period teacher's name. If it appears here, you need to see where you will end up going. Like if your third period teacher is giving the test, you need to look way over here to see where your class will be relocated during that period. Or you can also look down here because some of the teachers on the 200 hall are also relocated. So like if you have Mr. Gibbs, you'll go to room 55 that day, or Miss Cole, you'll go to room 11 during that time. Not y'all. I'm doing this for third period because they obviously don't have me for second period. So y'all are all going where I told you at first. You are all going to M16 is what I said? Oh, it's at the bottom. Yes, I will be with you. It's one of the trailers. Okay, so now let's go on to Monday, May 7th, which is the second day of juniors lit testing. During that day, it's during a fourth period. So get your fourth period teacher's name in your head. Look on this list and see if they're there. Okay, that means you'll be testing in room 212. I don't know why it's highlighted, but yeah, if you have Miss Miller for 8th period for American Lit, you'll be testing in room 212. So write that on your schedule. And you would have also been doing the same thing the previous day. Yeah, 212. Okay, so does anybody else see their teacher on this list? Okay, who is it? Miss B. Okay, she's giving somebody's test, so all of her classes will be relocated to room 113, Mr. Crawford's room. So he'll be watching y'all that day. Okay, does anybody else see their fourth period teacher's name on this list? Okay, what about below for relocation? Math teacher, math teacher. They're all math teachers, so you shouldn't have those. Okay, so everybody should now know where they're going that Monday. Yeah, if your name's not up there, you'll go to your normal fourth period room. And your normal fourth period teacher should be in there unless their name's up here. Okay, so now let's look at Tuesday, May 8th, which is when you take your Algebra 1 test. Okay, now obviously all of you have me for second period. You will be in this room with me. So on the Algebra 1 EOC, yeah, I'm testing y'all. So write 207 on that day. Yeah, y'all could put normal. On the Algebra 1 day, the May 8th day. Now for my third period classes, they will be in room 210, which is just right across the hall diagonal and with Mr. Campbell testing. If you are not, oh, never mind. Mr. Campbell's class is relocated, but y'all don't need to know that. Okay, so does everybody have Tuesday, May 8th? You know you're coming here. Okay, yes, Kaylee? No, you don't really care about that. You're coming here for the testing period. First, you'll go to 10-minute attendance, and then after that, you will go to my room, 207. My third period will go to room 210. Okay, we'll do one more day, the geometry day. So it's during a long second period, which for y'all that's with me, and I'm not testing. Well, no, because my room's used for testing. So we'll be relocated to a trailer, M11. Now, if you're in my third period class, you need to look on here and get your second period teacher's name in your head. Don't listen. If your second period teacher is up here, you need to see where you've been relocated. Okay, or you need to look down here and see if your second period teacher has been relocated.